All right, everyone. I wanted to just take a video of me working this example. That's the example in your notes. So you could come back to it and just listen and kind of follow along as I work through it. So this is the example. That's the first one in your notes. So it looks like we're starting with a reaction between hydrogen and oxygen gas to form water. And it's telling us that we start with 2.90 grams of hydrogen and 20 grams of oxygen. And it's really wanting to know how much of this we're going to form. So because we're starting with two different masses here, we need to determine which one of these two starting reactants is actually going to be consumed first and will then limit how much of the final product, in this case water, we're going to make. So step number one is to convert both of these gram starting amounts to the product. And you can determine which element is going to be sort of consumed first by stopping just at the moles of water in this case. But I kind of go all the way to the end and I just do a grams to grams calculation. And so I'm going to show you that method too. And I'll along the way tell you where you can stop. So I'm going to start with hydrogen. So this is hydrogen as my starting amount. And I'm going to take my starting amount and I'm going to just do a stoichiometric grams to grams conversion of hydrogen to water. So I'm going to start with 2.90 grams of hydrogen. First step is going to convert to moles. Mass. So I'm finding this amount on the periodic table. This is 2.02 grams. Okay, so that cancels. Now I'm left with moles of hydrogen. So now I'm converting, if I have that many sort of moles of hydrogen, how many moles of water would I produce? And it's a 2 to 2 ratio here. So I'm going to have moles of water in the numerator such that my moles of hydrogen can cancel. Previous step. And then the last step here is to convert this number of moles to grams. I'm going to calculate the formula mass of water, which is 16 for oxygen plus 1.01 times 2, and that is 18.2 grams of water for every 1 mole of water. All right, so I'm left with the unit that I want, which is grams of water, and I'm going to calculate a value of 25.870 or 25.9 grams with that amount of starting with 2.9 grams of hydrogen. So now I'm going to do the exact same thing, except I'm going to start with my 20 grams of oxygen. So a lot of this is going to look exactly the same. So this initial step is going to be oxygen. So will my stoichiometric ratio. So 32 grams. Now I am looking at 1 mole here for every 2 moles. Canceling, and then this step is just exactly the same. This is going to give me 22.525 or 22.5 grams. All right. Now, what this is telling me is that when 2.9 grams of water are completely consumed, that's going to be able to theoretically produce this amount of water. And 20 grams of oxygen is only going to produce this amount of water. So what that means is with those two starting amounts, I can't produce the exact same amount of water. So the one that is going to be the amount of water I'm actually producing is the one that is the least amount. That means that this guy is going to be completely consumed and is the limiting reactant. And then once this guy is all done, once I've consumed those 20 grams of oxygen, then the reaction stops. I don't have enough of my starting ingredients to produce any more water, and so I'm left with excess hydrogen that is left unreacted. All right. And the theoretical yield, or the amount I'm going to produce, is the lowest of those two numbers that I just calculate. So my theoretical yield is going to be, rounded to sig figs here, 22.5 grams of water. So that's how you determine the mass of water that will form, which is this amount right here, and then which is limiting. Okay, so now I've identified the limiting and the excess reactant. Now, the next part of this question is asking me how much of the excess reactant will be left over. So it's basically telling me I know that 0 oxygen will be left over because it's completely consumed, but there's an amount of this hydrogen gas that's going to be left. And there's 2 ways you can do this calculation. All right, so the first way, I'm going to show you both of these ways. Method number 1. Actually, let me do this in another color. Method 1. And basically, both of these methods are going to incorporate a subtraction step and a stoichiometry step. And it just depends on the order in which you do those 2 steps. You get the same answer both times. Just sort of makes whichever makes the most sense to you. So method number 1 is you're going to do the subtraction step first. And what you're going to subtract is the difference in these 2 theoretical yields, because that's basically the difference that they could each make. All right, so I'm going to take the difference between the 2 theoretical yields that I just calculated, and they're both of water. You can see I've rounded to sig figs here. All right, so there is, I'm going to subtract those 2 numbers, and this is going to give me 3.4 grams. So the difference in the amount of waters I could generate with those 2 amounts of reactant, the difference in those theoretical yields is 3.4 grams. And I want to just make a note here that I just dropped sig figs. So I started with 3 here, and now I'm down to 2. So now my final answer, I'm going to do some additional manipulation of this 3.4 grams number. My final answer needs to be to 2 sig figs. So now that I know the difference in these 2 theoretical yields, I'm going to convert this amount of water back to grams of whatever substance was in excess, which in this case is hydrogen. So now I'm going to do a gram to gram conversion just backwards, right? I'm going to now convert this number back to grams of hydrogen, right? So I'm going to start with 3.4 grams of water, and I'm going to do basically these in reverse, okay? So now I've got the molar mass of water for every 1 mole. And looking back, I've got 2 moles. Let's see, where are you? Oh, it's not letting me roll. Let's see, 2 to 2. I've got 2 moles of water in the denominator this time, and 2 moles of hydrogen. Now, 1 mole hydrogen for every 2.02 grams of hydrogen. And this is the amount that will be left over unreacted in that reaction vessel. And again, it needs to be to 2 sig figs, and this number is 0.38 grams of my excess reactant hydrogen. Okay, now a good logic check here. This number that you calculate should be less than what you start with, right? Does that make sense? Because you've consumed part of it and are left with some of it, like there's some remaining. So if you get to this point and you've gotten a number that is like more than what you start with, then you've made an error somewhere. So that's a good place to sort of check that you have made an error. All right, so the second method, again, is the exact same, except I'm going to do the steps sort of in reverse. So the subtraction step is second this time. Okay, so now what I need to do is I need to take I'm going to start with the mass of the reactant that I just calculated, my theoretical yield, so 22.5. 22.5 grams of H2O. Now, remember that I calculated the amount of grams, 22.5, starting with oxygen. So that's how much I can form when I completely use up my oxygen. But now I'm going to take 22.5. I'm going to see how much I would actually use of the hydrogen in order to make those 22.5 grams of water. And then I'm going to subtract it from what I start with. So this is my theoretical yield that I just calculated. And I'm going to do this exact same thing. All right. It's going to be redundant. This is literally the exact same. Okay. And this number is going to give me a value of 2.52 grams of hydrogen. Now I'm going to take the amount that I started with, 2.90 grams. That was from my problem, 2.90 grams. And I'm going to subtract the amount that I consumed. So this right here is the amount that I consumed. So I'm going to subtract that amount. You get, surprisingly, 0.38 grams. Okay, so what this tells me is this is how much I started with. In order to generate 22.5 grams of hydrogen, I need 2.52 grams of hydrogen. Sorry, this is water, so 22.5 grams of water. I need 2.52 grams of hydrogen. That's going to leave me with 0.38 grams of hydrogen in excess. All right. And that is a limiting reactant problem. That is all of the steps. So again, this number should be, you're going to do a logic check here. Again, checking to make sure that that's less than your starting value. Now, what that means is I started with a certain amount of molecules of hydrogen and a certain amount of molecules of oxygen that correspond to 20 grams and 2.90 grams. And when they react together, all of those 20 grams of oxygen have been converted to water, and then I'm left with, in the reaction flask, water and the leftover hydrogen in the amount of 0.38 grams. And then I've made 22.5 grams of water, and that's what's left in my reaction vessel. Okay? And there you have it, limiting reactant problems.